In this video, we're going to be dealing with electric forces and fields. So Coulomb's law is the equation that governs the force between two electric charges. It can be written as K Q1 Q2 over R12 squared. K is the same as 1 over 4 pi epsilon naught, and that's 9 times 10 to the 9 Newton meter squared per Coulomb squared. Epsilon naught is the permittivity of free space. It's a measure of how strong an electric field is given the medium. So permittivity of jello would be different than permittivity of a vacuum, for example. But epsilon 0 is for a vacuum, which is pretty well the same as air. Now you must remember this is magnitude only. As far as direction goes, you have to work that out yourself. So you will be dealing with a lot of questions where you've got charges lying on the x-axis, Q1, Q2, and then possibly another charge over here, Q3, and you will be asked to calculate the force on Q3. So you have to work out these directions yourself. Q2 and Q3 are going to repel each other, so the force on Q3 due to Q2 would point to the right, and that would be K Q2 Q3 over R23 squared, where R23 would be this distance here, and that's just a distance. That's not a vector. And then the interaction between Q1 and Q3, they would attract one another. So F on 3 due to 1 would be K Q1 Q3 over R13 squared, and R13 would go between R1 and R3, and they would point in opposite directions. So if the one to the right were stronger, then the net force would be to the right. If the one to the left were stronger, then the net force would be left. But notice how you do not put negative numbers into this equation for F equals K QQ over R squared. You must draw the vectors and work that out. Now, a lot of the questions are interested in having the net force 0 on that Q3, in which case the magnitude KQ1 Q3 over R13 squared would equal the magnitude Q2 Q3 over R23 squared. K's would cancel, Q3's would cancel, and basically you've got these four variables, Q1, Q2, R13, and R23, in order to manipulate whatever you're asked for and whatever you're given. But notice no negatives here. So even though Q1 is negative, you do not put that in. So good idea would be to put like absolute value signs here, absolute value signs. Don't put negatives in there. Okay, so that's a common kind of question that you'll be dealing with. Now, electric fields, there doesn't have to be a charge there. So if you have the same scenario with Q1 and Q2, and then the question says, where is the electric field 0? Now, it's never going to be 0 between the two charges, because if you put a little test charge there, it's going to be pushed left by Q2 and pulled left by Q1. So it's never in the middle, that if you have opposite charges where E is 0. But it is possible out here that E could be 0. But that's only if the magnitude of Q2 is less than the magnitude of Q1. You need to be on the side of the smaller charge. So this would be the smaller one because you're closer to it. And so they compensate each other. Being closer and having a smaller charge, it's possible for the electric field due to this one, which would be this way, E2, would be KQ2 over R2 squared. R2 would be this distance. That would be to the right because it's a positive charge. The electric field from Q1 would be the opposite direction, towards the negative charge. That would be E1, which would be KQ1 over R1 squared, and R1 would go over here to Q1. And so it is possible the electric field is 0, and you don't need to put a charge there. And you'll notice the equation is basically the same, that Q1 over R1 squared is Q2 over R2 squared, and that's the very special point where E is 0. No negatives here. These are all positives. Okay, you've dealt with the fact that the electric field is points right, points left, they cancel. Okay, also in this chapter, that's really all the kinds of questions that you're going to be dealing with. So it's Coulomb's law. Is the electric field due to point charges? So a point charge Q1 has an electric field everywhere around it that points radially out like this. That would be E, which would be K Q1 over R squared, where R would be the distance from the center of the charge to the point of interest. Okay, that's all you need for this chapter. Lots of good videos to watch, lots of good examples on your PowerPoints.